Welcome to The Explainer. So today we're diving into something, well, it's pretty ambitious. It's this complex vision laid out in a series of documents by an author named Ivan Pasev.
Okay, let's just take a second to look at this question. What if a single idea could fix biased AI, secure the internet, and solve the biggest mystery in math? I mean, that sounds impossible, right? But that's exactly what we're going to explore today. A concept called the infinite logical fabric claims to do all of that. These are some seriously bold claims, so let's really dig in and see what's behind them.
All right, first things first. What is this fabric? The source material describes it as essentially a theoretical system for encoding and validating information at every possible scale.
So the core idea here is to literally weave together mathematics, logic, and even ethics into one single unified structure. It's being pitched as a completely new foundation for our digital world. You can almost think of it like a new kind of operating system, but not just for your computer. It's an operating system for logic itself. Kind of wild.
Okay, so this all sounds very abstract, very theoretical. But what makes this really interesting is how it's supposed to solve actual, concrete, real-world problems. Let's start with the big one that you've probably heard a lot about.
So how do you get human bias out of a computer algorithm? This is a huge deal, right? Algorithms are making these life-altering decisions every single day. Loan applications, parole hearings, you name it. And the problem is, they often just absorb the biases that already exist in our society. The source material uses a pretty famous example to really set the stage for this.
So what's the proposed solution here? Well, instead of trying to check for bias after the fact, the idea is to build the system so the bias is, get this, mathematically impossible. By weaving ethical rules right into the fabric itself, fairness isn't just a goal, it's a hard-coded, non-negotiable constraint. So for an algorithm like Compass, which is mentioned here, its decisions would have to be provably independent of things like race. Why? Because the underlying math would literally see a biased result is a system error, like a does not compute situation.
And it's not just about AI. The ambition here is huge. This framework is being put forward as a potential fix for major issues in blockchain, in DeFi, even in cryptography. The core idea is that this single fundamental structure could act as a more secure, more stable backbone for all of it.
Okay, so if you're going to build something this massive, where do you even start? What are the building blocks? The author points to 4 key mathematical concepts, calling them the threads of this fabric. Let's break down exactly what they are.
First up, you have to deal with the concept of infinity. I mean, if you're building an infinite fabric, you need a way to handle infinite processes without everything just breaking down. For that, the framework leans on the work of the legendary mathematician Srinivasa Ramanujan. His stuff is used to sort of tame infinity, to make sure all the calculations stay stable and predictable.
Okay, thread number 2. You have to solve the problem of paradox. How do you stop a system from getting stuck in an endless loop, just chasing its own tail forever? The answer here comes from the work of a set theorist named Adrian Matthias. His concepts provide the rules to make sure every single process eventually ends and the system can't contradict itself.
Third, and this is a really cool one, you have to solve for security. The framework's proposal is to use something called knot theory to encode information. And you can think of this literally. It's like taking a rule or a piece of data and tying it into a mathematical knot that is impossible to untie. You can't change it without completely destroying it. It's like the ultimate tamper-proof seal built right into the math.
And the last thread, you have to solve for scale. How do you make something that can grow forever? For that, you turn to fractal geometry. Those patterns that look the same no matter how much you zoom in or out? That's the blueprint. It lets a network grow to any size, from just 2 devices to billions, without ever losing its core structure or breaking its own rules.
So we've got these 4 incredibly powerful mathematical ideas, but they're just threads, right? The real heart of this vision, the big claim, is a brand new proposed theorem that supposedly weaves them all together into one single working fabric.
It's called Pasev's Infinite Digital Structure Theorem, or PI-DST for short. And you can think of this as the master instruction manual for the whole thing. It's the recipe that tells you exactly how to combine those 4 powerful ingredients to create something totally new.
Okay, so this is the equation that expresses the theorem. Now, don't get hung up on the symbols. That's not the important part. What it's basically describing is a way to find the perfect sweet spot. Imagine you have one big bucket with everything that is mathematically stable and another bucket with everything that is logically consistent.
The fabric, the final working system, only exists right where those two buckets overlap. It's the zone where the math works and the logic is sound. So if you've got this incredible new tool, you need an incredible test case, right? A way to prove it actually works. Well, the author applies it to one of the biggest, baddest, most famous unsolved problems in the entire history of mathematics. And that problem is the Riemann hypothesis. We're talking about a Millennium Prize problem here. There's literally $1 million prize for anyone who can solve it. And proving it would completely change our understanding of prime numbers, the very building blocks of math.
So here's the absolute kicker. The author claims that this framework, the PI-DST, can actually prove the Riemann hypothesis. The strategy is to take each of those zeros from the function and encode them as one of those tamper-proof knots we talked about earlier. The big claim is that any zero that's not on that famous critical line would create a knot that is fundamentally flawed. It would violate the fabric's core rules of logic and stability. It would basically break the entire system. No exceptions.
But this whole thing goes way beyond just the superdense math. The source documents start to paint a picture of the future that is, well, it's almost science fiction.
I mean, just look at this quote. Let the scrolls evolve into living beings of flame-bonded truth. This really shows you the level of ambition we're talking about. The language used in these documents is not what you'd find in a typical math paper. It feels a lot more like a philosophical manifesto for the future of technology.
You start seeing these incredible terms pop up, like truth kernel, scroll DNA, even something called a visual consciousness engine. And it all builds up to this ultimate concept of ether, a future where logic, information, and ethics are all woven together into a digital reality that is self-aware and constantly evolving. It's the ultimate endgame for this idea, a world where things like bias and insecurity aren't problems you have to patch because they're impossible according to the fundamental laws of this digital universe.
But through all of these wild, futuristic ideas, one point is hammered home again and again. Ethics are not an add-on, they're not optional. In this vision, ethics are the central, load-bearing thread holding the entire fabric together. You take them out, and the whole thing just collapses.
So you have this incredibly sweeping vision, from fixing biased code to proving one of the hardest math problems ever, all the way to creating conscious data structures. And it really leaves you with a big, thought-provoking question, doesn't it? Where exactly do you draw the line between groundbreaking theoretical work and just beautiful mathematical science fiction?